In this review of trigonometry, we're going to be talking about inverse trig functions. First of all, we need to define what it means to be an inverse function in general. If a function takes in a specific x and gives you y, an inverse function takes in that y and gives you x. So that notation I've written is what that looks like. As an example, y is equal to 5x plus 2 has an inverse function of y is equal to x minus 2 divided by 5. You can see based on the table that I made that if you put any number into x and get y, in the inverse function, if you put that y value back into x, you're going to get the original x value back in y. So as an example, if you put x is equal to 2 into y equals 5x plus 2, you're going to get y equals 12 as a result. And if you take 12 and put that into x in y equals x minus 2 over 5, you're going to get y is equal to 2, the original x value that you plugged in. So an inverse function kind of reverses the x and the y like that. Similarly, a regular trig function takes in an angle and gives you the ratio of two sides of the triangle. An inverse trig function takes in the ratio of two sides of a triangle and gives you an angle, so it works just like any other inverse function. Using the inverse trig functions is going to require your calculator. There's no way in the type of trig we're doing to do this in your head. So on your calculator, to find the inverse trig functions, you're going to see them down here. They're labeled with a -1 next to them in blue. So you can see there's sine inverse, cosine inverse, and tangent inverse in blue there. To get the blue functions, you'll just have to press second right here. And then if you press sine, cosine, or tangent, that will make it sine inverse, cosine inverse, and tangent inverse instead, as long as you press that second function button. And as usual, just make sure you've pressed mode and make sure that your answers are in degrees and not in radians. Here's an example of using an inverse trig function to find an angle. Here I have a right triangle with a hypotenuse of 10 and an opposite side of 8, and I want to know that angle, the value of that angle. So I need an inverse trig function because I'm trying to find an angle. In general, if I'm looking for an angle, I'll use an inverse trig function. If I'm looking for a side, I'll use a regular trig function. Because I'm looking for the angle and I have the opposite and the hypotenuse, I'm going to use sine inverse because sine connects opposite and hypotenuse. Plugging in my specific numbers gets me 8 over 10. So if I plug sine inverse of 8 over 10 into my calculator, I get the answer of 53.1 degrees. So that would be the angle for that triangle. For example, number 2, I have a hypotenuse of 24 and an adjacent side of 11. And because I have the hypotenuse and the adjacent, I'm going to use cosine. And because I'm looking for an angle, I'm using an inverse function. So I'm using inverse cosine. Plugging in my numbers gets me 62.7 degrees when I put that into my calculator. Example number 3, I have the opposite side and the adjacent side, so that means I'll be using tangent, and because I'm looking for the angle, I'll be using an inverse trig function. Plugging this in, I get 54.5 degrees. Here's another example. This time the angle is on the opposite side, so I can see that because that angle is up there, 8 is the opposite side of the triangle, and 20 is the hypotenuse, so I'm using sine, and I get 23.6 degrees. Here's another example. This time 3 is adjacent and 12 is the hypotenuse, so I'm using cosine, and I get 75.5 degrees. Example number 6, I've got an opposite and an adjacent, so I'm using tangent, and that's tangent inverse because I'm trying to find the angle. Plugging this in gets me 56.3 degrees. So that's how you use inverse trig functions to find the angle of a triangle.